Good morning. I am Armin Ellis. I have 14 years of experience in the aerospace industry, a PhD in optical instrumentation, and I had a previous company doing aerospace components, which was acquired in 2007. I'm very excited to tell you about my next venture, which is Pine Aerospace, where we detect and monitor oil spills and offer a service that's badly needed for the industry at higher quality and at lower prices. Now, we all remember the Deepwater Horizon tragedy in 2010. Some 4.9 million barrels of oil were released in a matter of 85 days. What's tragic here is that this cost is really associated with the damage that was caused to the Louisiana coastline. Now, BP has put a fund forward for about $20 billion to remedy that, and that cost could potentially go up to about $100 billion. Now, if there was only better data on the oil spill, and if we had more situational awareness of what was going on, the right tools could have been used at the right time, and that coastline could have been better protected, and a lot of the costs could have been reduced. What's also interesting here is that statistics from 2010 and 11 show that there have been 24 major oil spills. That's one a month on average, which is quite surprising, actually. You know, in the aftermath of Deepwater Horizon, industry understood that there was a problem with public perception, and they decided that they were going to get together and create research funds to look at this problem a little further. Governments also, having taken the cost for this monitoring activity, were also in agreement that there has to be some new way for active monitoring. At Pine Aerospace, we have come up with a solution that has three components to it. The first is instrumentation. Now, this instrument is very good at looking at water and distinguishing it from oil. We don't do mapping. This is the domain of conventional Earth observation satellites. That's not what we're competing against. So, for example, if you look at the image on the left, this is what you would get with optical instruments from traditional Earth observation satellites, and our solution in Pine Aerospace is to provide what's shown on the right. Fundamentally, what's on the right is not derived from what's on the left. Okay, so this is new technology. And also there's additional things that we can do in the agricultural field as well. The second part of our solution is an interesting way that we deploy our system. Although the components, many of our colleagues have done a fantastic job of creating subsystems. We're not in the subsystems development business. We'll just purchase those. But also what's important is the data handling system. What we do is that we process this data and do so at a very innovative manner and supply it to smart devices where individuals on the field can use where they need it. So as many users who need to be aware of the situation in the field, that's a very important thing to take home. Our system is protected by patent, and takeaway message here is that it's scalable for Pine Aerospace. Servicing 5 rigs anywhere in the world costs the same amount as servicing 500 rigs. Very analogous to GPS and navigation systems. Also worth remembering here is that we lower the cost to industry. Right now, instrumentation costs could be over $100,000 per rig, and we can reduce that substantially through a traditional subscription system. Now, our implementation strategy can best be described as a test-as-you-design strategy. And we have a UAV program where we test the algorithm and work with our instrument to make sure that the space segment is developed in parallel with our UAV program. And furthermore, we have a beta program where we bring in our clients. Currently, we're working with 2 of the top 10 oil industry partners. And we believe that the beta program will allow us to better understand what they need, and furthermore, turn those beta customers into paying customers later on. Just to mention the team, you guys have the resumes. I think we've got the technical side very well covered. We also have tremendous experience in finance and marketing. A little bit about the market size. Right now, we're looking at 400 deep sea rigs that are out there, and This number is due to go up by 12% per year as we drill into deeper and deeper and less accessible oceans. What we'd like to do is to capture about 30% of the market, and we're confident, having spoken to our early customers, that we can meet our second-year revenues of $3 million. A little bit about the risk mitigation here, because this data is also useful for governments and environmental groups and has lots of agricultural applications such as water management. And our exit strategy is very standard and expected within 3 to 5 years. Thank you. I'm willing to take questions now.
So I'm wrestling a little bit with the value proposition here with your customer. If we remember the BP oil spill, there were cameras that were providing image under the water.
That's right.
And they weren't very happy about having them there and having the information available because of the liabilities associated with it. So I'm kind of want to probe a little bit deeper here about the value proposition, particularly for the folks whose rigs that you're going to be looking at,
yes.
And kind of the risk issues. I mean, even if you're selling to government organizations and getting them to the pay, they have very strong lobbying groups, which ultimately are going to influence the ability to pay for these kinds of things.
Absolutely.
Have you looked at the risks around that? Because if I'm running a major oil company and I've got a major oil leak out there, I'm not sure how happy I am about all the information. I mean, I think ethically it's a great thing, but I worry about that. So maybe address that a little bit.
I think that's actually a very interesting point to raise. I think Deepwater Horizon changed everything. I think it opened up the understanding that the public had about the oil industry. And frankly, with BP having to shell out $20 billion, and as I say, it could go up to $100 billion, I think that the game has changed now. There's more awareness than there was previously. And they're actively doing things. I mean, I fundamentally don't think they're bad guys. I think that I think you need to give them the right tools to do the right things.
Have you considered, going the route of a hosted payload on someone else's constellation as opposed to putting up your own? I mean, skybox imaging, for instance. Maybe too late for Orbcomm or Internet or Iridium, but do you really need to have your own dedicated constellation and all the headaches that involves?
Well, that is an interesting point. Yes, we have looked into it. It's an alternative method for deployments. Okay. In 6 minutes, there's only so much that you can discuss, obviously, but that is a very interesting architecture, and certainly I think that once we go through the UAV test, as we design the instrument, we have to look at the compatibility of it. But certainly I think that is a good option to go forward with. Yes.
I can see and you didn't talk much about the agricultural monitoring, but I can definitely see markets in both of these areas. I guess my biggest question is that part of this whole business plan is about space enabling. So you're using space for terrestrial applications,
yes.
But does it do anything to enable future space development as well? Okay.
Again, I think that's one of those key things. As many of you know, I am space through and through. One of the things that I believe is that we need applications. So you can build a bridge, but if it goes to nowhere, there's no point in having it. But if you do have lots and lots of applications, the people who are developing the subsystems will buy them. We don't want to get in that business. There's people who are creating rides. We'll take them. And the infrastructure, I think, really is what we'll be supporting and making this really relevant for day-to-day applications as well.
I have a related question about the scale-up of this service.
Okay.
On the one hand, you said that small sensor that was in the photo, you said you need 6 of those on a CubeSat or a platform to do the data set you really want to get.
That's right.
And that seemed pretty big to put 6 of those on even a 3U CubeSat. So that's my first question. The other one was to really provide the value proposition of timely data return for these rigs, like on a daily basis at least.
Yes.
You need more than 5 satellites. You probably need dozens or something to get that timeliness. So do you have in your mind, do you have a clear path to shrink this sensor down so you can get 6 on a satellite and then get something like a few dozen of those satellites up for a reasonable price and still offer that service for a reasonable price?
Yes, okay. So the first question about the sensors, absolutely, yes, we do need 6. And really, we've proven how it works. It's just a case of packaging. I don't see any technical development risks on that front.
And you're, I'm a little curious about your link budget here, because you're doing this in LEO, but you're providing imaging, right?
Yes.
And those things move pretty quick. So kind of ground station cost and support, I mean, do you see any issues there? Because
Okay.
you're moving a lot of imaging information over very low bandwidth links.
Excellent point. So there is a fundamental change to the way that this data processing is handled. Okay. One of the things that I'd mentioned in the actual document is that is our particular approach that is actually patented. This is a very different way of looking at how you manage that data flow. So, as a space architect, that's obviously one of those key requirements to look at. And I'd be happy to talk to you about the
That was
details.
the on-orbit processing that you were trying to do?
A huge amount of it, so that you're actually dealing with data rather than raw images.